Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called meeting room second. So this is the second part of the similar problem. First part is just asking like whether these are the time intervals and whether the person can attend all these meetings or not. This is the second part where we have to find like how many conference rooms are required for the given time intervals. So let's try to understand this problem first of all. So let's see if I copy these time intervals to whiteboard thing, and let's say I am having one time interval 0 to 30, and so let's first of all read through the problem. So given an array of meeting time intervals consisting of start and end time, and find the minimum number of conference rooms required, right? So we need to find the minimum number of conference rooms required. So one conference room is booked from 0 time. So time is like just unit 0 unit to till 30 unit, and another room is booked from 5 to 10, so 5 unit till 10 unit, and another conference room, let's say, is booked from 15, so 15 will be like something here. Or let me just do this control Z here, and let's make it more realistic thing. So 0 till 30, and then 5 to 10 will come here, and then 15 to 20 might be come here, right? So this is one time unit, and then this is another required time unit, and this is another requirement that I need to find the time conference room for this time slot as well, 15 to 20, right? All right, so if this conference room is already booked from 0 time unit till 30 time unit, and I have to book another conference room that will run from 5 unit. The meeting will run from 5 time unit to 10 time unit, right? So definitely I cannot use this room, right? So let's say this is room 1. I cannot use room 1, right? So I need another room. So I will book another room 2 here, and for that meeting will happen from time unit 5 till time unit 10, and then let's see this time unit 15 to 20. So what will happen till time 10, time unit 10, this room will be empty, right? So I can reuse the same time room 2 from time 15 till 20. So basically here in this case the output would be 2, because I need the 2 conference room to run all the meetings to the given time intervals, as per the given time intervals, right? Now let's consider another example that's called 7, 10 and 2, 4. So 2 interval has been given, and that's 7, and then 10, and another time interval has been given, that is 2, and then 4. Of course that is not order. 7 comma 10 is first, and then 2 comma 4 is another, but let's be realistic from the time perspective. So this is from time 2 unit till time 4 unit, and this is for time 7 unit to time 10 unit. So let's say I booked one conference room here, right? And if I booked one conference room here, then this after 4 or till till 4, this room 1 will be filled, right? And after time 4 this room will be empty, right? And then these guys, whoever the meeting is 7 till 10, they can use the same room. So in this case the output would be 1. So this is the part of the problem, and we can just walk through the examples and just to understand the problem, like what the actual problem is and what we are going to ask. So let's hypothetically, let's say I have another time intervals, or like let's say 5 and then till 10, and another time interval I am getting 7 till, let's say, 8. Another time interval I have been given 6 till 15, and I have another time interval 17 to 20. So these are my numbers. I just made these numbers 5, from 5 time unit till 10 time unit, 7 till 8, 6 to 15, and 17 to 20. Now let's see. Let's say if I booked the conference room on this time, conference room 1, right? If I booked conference room 1, from that conference room 1 will hold the meeting from time unit 5 till time unit 10, right? So this room is already occupied and I need another time slot, that is 7 to 8. So I will book another conference room 2 that will hold the meeting from time unit 7 till time unit 8, right? Maybe it will just 1 unit of the time, but still this conference room 2. Here I need another conference room because this is occupied 5 to 10. This is also occupied 7 to 8. And then now I booked another conference room that will hold the meeting from 6 to 15, right? So now I booked 3 conference room, and now I need the meeting that should run in between 17 to 20 time units, right? So in this case I don't need to book any other conference room because conference room 3 would also be available till time 17, conference room 2 would also be available, and conference room 1 would also be available. So all these 3 rooms are available to run this meeting in between 17 to 20. So in fact I can reuse the meeting earlier conference rooms that I already booked. So in this case the output would be 3. So because I booked the 3 conference rooms. So this is the part of the problem. We just went through like 3 examples here. Now let's think about the solution part of this problem. So the solution part is of course the couple of observations when we were just going through the examples here, that we are checking if our end time of one time interval, if it is less than to the next time interval, then definitely what we can do, we can just reuse that conference room, right? So 15 is less than 17, we can reuse this conference room. 8 is also less than 17, we can reuse this conference room as well. 10 is also less than 17, so we can reuse this conference room, right? We don't need to book any other conference room. That's first observation. And if we think about like exact opposite thing, so exact opposite thing is like if we see like 8 is basically is greater than 6, right? So here the start time of conference room 3 is 6 and conference room 2 end time is 8, right? So if and 8 is greater than 6 means we cannot reuse the conference room, right? So end time should be less than the next start time. And if it is exact opposite means if it is greater than, then we cannot reuse the same conference room, but rather we will need another new conference room. So these are two observations. In fact, one observation is like it should be end time should be less than, then we can reuse, and the another observation would be exact opposite, like if it is greater than, then we cannot reuse, we will need a new conference room. And to apply this logic, we would need to sort basically this time. So for example, this 7 8 is in some other, if 7 8 is coming before 5 10, I need to get this 7 8 after 5 10, right? So let's consider the second example. 7 10 is before 2 4. So what I need to do, 2 4 should come before 7 10 so that I can just calculate it accurately whether it's to apply this logic, right? So first time, end time, whether it's greater than or smaller in comparison of next time interval start time, right? And to apply that logic, I need to sort these start time and end time. Once I can do that, then I can apply this logic and I can just easily check that how many conference rooms are required. So let's do this. Let's create couple of placeholder, and then we can come back and we can try to understand what we are trying to do. But at this point, let's say uh, some base condition would be like if intervals itself, if it is null, or this length is 0. In that case, we don't need the conference room would be 0, right? Now we need to sort start and end both the time. So let's go ahead and sort these. So I would do intervals, and because this is a two-dimensional array and we want to sort start time, and that's the part of one-dimensional arrays, right? So different one-dimensional array, and one-dimensional array is like the time slot is containing start and end time. So what we need to do, first of all, we need to sort with the start time, and we will sort with the help of end time as well. So we need to add our comparator here. Why we are adding the comparator? So that it can sort our start time inside the two-dimensional array, right? So two-dimensional arrays consisting all these one-dimensional arrays, and these one-dimensional arrays holding the start time and end time, and we want to sort basically these one-dimensional arrays based on the start time. So what we will do here, we will just do the one-dimensional array, and intervals itself is the two-dimensional array, and then we are adding this comparator. Means inside the two-dimensional array we will pass this one-dimensional array, and in the one-dimensional array is nothing but these all the time slots, and then we will tell our comparator, okay, just do the sorting based on the start time. So start time is nothing but it's the zeroth index of each interval. Alright, so let's go ahead and do this. Public int compare, and so int a comma int b, return a0 minus b0. So why we are doing this? Because so basically first array 0, first array start time, and second array start time is 5. We are doing a minus b because we want to sort them in the ascending order. If we are doing reverse here, b minus a, that it means we want to sort in the descending order. So that's we did the sorting on the start time, right? So we did the sorting based on sort start time, right? Now we want to do the sorting for the end time as well, right? And to do that, because we already used here the built-in method that's called sort, so let's go ahead and do the end time with the help of priority queue. So priority queue, the same thing we will do here as well. New priority queue, new comparator, int array, and I think I can copy paste this guy here. The only difference would be I would be passing a1 minus b1. So a1 is the second index, I mean second time. So when I say second, it means the first index. So this is the 0th index and this is the first index, right? So first index, right? So start and end time, and first index is the end time. So that's why we are doing a1 minus b1. Now we need to apply our logic that we just discussed, right? So let's go ahead and apply that logic. So int, this is our time slot interval, and we are iterating through the two-dimensional array. Now what the pattern we just saw here, so let's say 6:15, and then this end time, if it is less than the next time interval start time, then we can reuse, right? So when I say reuse, what we can do, the priority queue we are already holding, so we can just poll from the priority queue. First of all, let's let's put all these guys in the priority queue itself, right? Let's go ahead do that, and then we can apply this logic. So we can do all those things at the same time. So if I do interval, means we are inserting all these intervals in the priority queue. Now let's go ahead and apply our logic. And what our logic says, if pq is not equals to null, in fact this would never be null, this would always be not null, so don't need to check this guy. So let's say if pq dot is empty, so if it is not empty, right? And so pq first time will be empty, right? So it will just add all these intervals, let's say in this example 5 10. So and then we can check this logic, like if our pq means priority queue that's already holding that interval, that's end time, whether it's lesser than or not. If it is lesser than, then in that case what we can do, we can simply pull from the priority queue, means we can just remove from our priority queue if it is lesser than. And in that case, if it is not lesser than, then we don't need to remove. So let's go ahead and do that. So pq dot peak, because they are pq dot peak, or so this will be interval. So pq dot peak means whatever in the top of the priority queue, right? So we are just so right now what we are doing, let's say 5 10. So 5 10 would be on the peak, and then we will be checking this end part with the next start time, start part. And let's go ahead and cancel this guy. So let's say this is first time slot, and the time slot is 15 20, let's say. So my priority queue will hold 5 10, right? So this would be in the priority queue. The next time would be 15 and 20. So the 10 is going to be checked with a 15, right? And if 10 is lesser than, means we can reuse, because one conference room is running the meeting till 5 till 10, from 5 till 10. And then after 10 this room will be empty, then we can use the same room for this time slot, 15 to 20 time unit, right? So that's why we are checking if it is end time, if it is lesser than interval 0, right? Because this is the one-dimensional array, and in the one-dimensional array we are just checking start time. And if it is the case, then go ahead and pull from the priority queue. And doing this in the end, let's say in this example, right? So 5 10 15 20. So 5 10 we already added in the priority queue. Then we go to this interval and we just check this end time that is lesser than the start time. Then what we will do, we will pull from the priority queue. So we will remove from the priority queue, and then we will insert this 15 and 20, right? So the priority queue size is 1 in this case, and our output would also be 1. So we can safely return here the pq dot size, and that would be our answer. Let's verify this with the other example. So let's say 7 10 and then 2 4, right? So what we are going to do here, 7 10. So let's say 7 10 I added in the priority queue. Then we encountered 2 4, and what we will check, we will check our end time, priority queue end time, that is 10, if it is less than or not. In this case, so you remember we already sorted the start time with the help of arrays.sort. So basically this will be 2 comma 4 and 7 comma 10. However, it has been given in the reverse order, 7 comma 10 and then 2 comma 4 in the example. But because we are already sorting based on the start time, so this will be like 2 comma 4 and then 7 comma 10. So in this case our priority queue will hold what? If I cross these guys, then our priority queue will hold 2 comma 4 and then it will come to the 7, and then priority queue end time will be compared with the start time, and that is this is the start time. So 4 is less than 7, then we will remove the 2 comma 4 from the priority queue. So we will remove this guy from the priority queue, and then we will add again 7 comma 10 in the priority queue. So our result will be 1 in this case. Now let's go ahead and check this example as well. So shift C and then control V. So let's say 0 comma 30, this is the first interval, and let's say we added in our priority queue. So let's say this is our priority queue. Okay, so 0 comma 30 we added in the priority queue. Then come the 5 comma 10. So 5 comma 10 means this end time that is greater than, that's not less than. So we will not remove anything in the priority from the priority queue, but 5 comma 10 we will add. So right now priority queue holding 2 elements, right? So first interval is this and second interval is this. Now let's move to 15 comma 20. So 15 comma 20, right? So 15 comma 20, before inserting, what it will check whether the end time, if it is less than to this start time or not. So it is less than basically this start time. So what we will do in this case, we will poll 5 comma 10 from the priority queue, right? Or in fact our priority queue was holding this, 5 comma 10 and then 15 comma 20. So we will poll this 5 comma 10, and after applying this logic we are again inserting 15 comma 20 itself in the priority queue, right? So now the priority queue will hold these two elements, 15 comma 0 comma 30 and 15 comma 20. So basically our result would also be 2 because we are returning the priority queue dot size. So while explaining, let me rerun this again. So let's say we are here 5 comma 10 and then we have the 15 comma 20. So at this moment it did not insert into the priority queue, but we are just checking. So 10 is less than 15 comma 20, right? If it is less than, then we will remove from the priority queue, and then we come here and then we are inserting 15 comma 20. So I just wanted to correct it diagrammatically as well, so that it does not add any other confusion basically. So now priority queue is holding 0 comma 30 and then 15 comma 20. So now the result should be 2 because we are returning priority queue size basically. Okay, so this was just for the computation. So this is our priority queue now. So hopefully this is clear. Let's try to see for the compiler errors if there is any. And in the meanwhile the time complexity would be n log n and the space complexity should be order of n, because we are just doing this n log n thing. So I think it's working fine. There is no compiler error, but there is a wrong answer. Okay, yeah, that expected, and I did not consider this case intentionally, just to showcase this edge case as well. So let's consider this thing. So let's see, what is this? 13, 15 and 113. So if I clear this guy, so one time interval is 113 and another time interval is 13, 15. So you remember, like, we are applying the logic is less than. So basically let's say my first interval come, that is 113, I inserted in my priority queue. Then my second is 13. So 13 is not less than, right? 13 is not less than, but it is equal to. So what I am doing, I am not polling from the priority queue, but I am just inserting. So in this case, the output is 2 as per our current algorithm. But in fact, the actual output or actual result should be 1 itself, because this conference room will be empty at the time 13, and exact the same time unit the other guys, they have the meeting from 13 to 15, they can also reuse the same meeting room, right? So we need to consider this case as well, and I made this intentionally just to explain this case. So we need to do it less than equal to, and that should solve this problem. So if we submit, then it should be submitting fast. Alright, so hopefully this was useful, and this was the whole explanation of this, what this problem is about, and how to visualize this problem and how to solve this problem. But before ending this video, just a quick summary. We have to find the minimum number of conference rooms required, so we just went through and we just check all these time slots. And here the one key observation is we are just checking the end time, and if it is greater than the next start time, then we cannot reuse the conference room. But if the end time is less than the next start time, then we can reuse the conference room, because the conference room will be empty. So this is the important logic and key observation here. And to apply this key observation, we need to sort our interval based on the start time, and we need to sort based on the end time as well. So here we are using built-in function, built-in API that's called sort, and we are adding our comparator as well, because we have to sort this one-dimensional array that's having the time slot, and we want to sort on the start time. To sort the end time, we are taking the priority queue, but in fact the priority queue use here is basically just to maintain the size. So priority queue we are using, but if we can reuse the conference room, we are just emptying our priority queue, we are just polling from the priority queue. But if we cannot reuse the conference room, then we are not polling from the priority queue, and that's how the priority queue always size is having the minimum conference room. So it's holding every time the conference room. So it's like straightforward if you think through, like if we are just putting all these time slots into the priority queue, but whenever it is needed to basically reuse the conference room, so reuse means this logic. So if already existing time slot, if it is less than equals to next time interval start time, then basically we can reuse. So reuse means we need to empty that conference room, and empty means we are to clear the priority queue, and then basically we are just making the space of the next time slot, and we are just adding that time slot, and similarly we are just applying the same logic for all the time intervals. At the end, in the end, basically our priority queue will be holding the correct size, means correct numbers of the conference room required. Hopefully this was useful. I would be sharing the GitHub link as well, having the same code. So just try to understand the approach, and then you can just refer the code from the GitHub link. Thanks a lot. Bye.